Hello.
Mr. Rosenthal,
Yes.
yesterday I wasn't here for the section review, and you told me that,
Yeah, the video recording had issues. I ran
yeah.
out of disk space.
So is it possible if you can go over the review again today, like after?
No, after, yes. Office hours, yes. Not during the main lesson. It's one of the benefits of being here during the lesson is that there's almost no chance of missing it. So I really recommend that if you can. I know sometimes you can't. I'm not blaming you. It's not your fault. It's just that everything has to keep moving forward. You know what I mean?
Oh, okay.
Yeah.
What question are we on right now?
We didn't go that far, and I don't think anything we did was too difficult.
Oh,
Let's see. It looks like we're on slide 8, so we only did 7 of the first 7 slides.
oh, okay, because I tried doing the review yesterday, but I stopped on the question before this one.
Perfect. Then you only have like one question that you need help on. After
uh,
the class, we can do it. No problem.
is it possible if you can go over that one, now? Or,
Well, no, we got to start class.
oh,
Yeah. So right after, it just takes a couple minutes. Just stay a couple minutes after, and we'll do it. Okay. I have it recording now. I freed up a couple files onto a flash drive. I ordered the wrong hard drive. I ordered an internal drive, and I needed an external. So right now, I got a couple of my videos on a flash temporarily, just to make space for today's video. So hopefully this all works, and that I can get this one up on YouTube. I don't know. Does anybody know how to recover? It did record the video, and then once it didn't have anywhere to put it, I don't know what happened to it. I don't know where it is. It could be lost. I might need customer support, or we're just not going to have yesterday's lesson ever. So if anybody knows anything, feel free to speak up. Right now, you're doing this algebra problem as it relates to geometry. You're finding little r, given big R and the area of the ring. I opened this room up because it wasn't recording, and that's because yesterday I had changed the setting to change the location of where the recording would go to my computer, and I forgot to change it back to the cloud, which I had filled up. I filled up that space, and I removed 2 of my videos. Hopefully that's enough to do 2 new videos today. Let's see what happens. I hate to lose even a single video that we had a good lesson on. Now I felt like yesterday was a pretty good lesson. We delved into things.
It was just arguing about whether we can make it.
Are we doing the circle problem or the find the value of x problem?
Doing both. I was going to say do this one first, and then we can get to the review.
Okay.
Calculate on this, right?
Whoa. It went to sleep, and when it came back on, it minimized my file on its own. Ghost in the computer.
Wow.
Let's see what we got here. So this constitutes the large circle minus the small circle. It equals 24. So we have pi r squared minus pi r squared equals 24. But you have big R, so you have 36 pi minus pi r squared equals 24. A couple ways you could do it.
Minus 24 plus pi r squared.
You could factor out a pi first. Get a difference of squares. Divide by pi. Now I'm going to come down here, divide by pi, and factor that into a difference of squares maybe. I don't know. Maybe not. 6 plus r, 6 minus r. I don't think that's going to do us any good. Equals 24 over pi. No, not helpful.
I think it's best to do pi r squared minus 20. I mean, pi large R squared minus 24 equals pi r squared. Because we
Then
already know.
R squared is equal to, I'll move that over there and that over there, 36 minus 24 over pi.
That's what I was going to say.
And then radius is equal to the square root of that. And let's go ahead and get our calculators out and get this to the nearest 10th. $36 minus parentheses 24 divided by pi button, close parentheses, equals, inside of here is 28.36, whatever that is. Take the square root to get R. 5.3.
Isn't the 36 negative?
No. How do you get that?
Like,
This step I added R squared to this side, and I subtracted 24 over pi here, but the 36 remain. And then I used the symmetric property to move them on the reverse sides of the balance scale. So I get R is about 5.33 centimeters.
By the power of estimation, I got 2 root 7.
Okay, round to the nearest 10th.
Yeah.
Round to the nearest 100th, round to the nearest 100th. And that's what you get. Are there any questions about this retro problem? We're going to be doing retro problems because after this test, I'm going to be this weekend building a curriculum for you guys, and I'm going to be discussing with Mr. Knaus. I've already had 2 discussions with him, but it's really going to be up to me and where I want to go with you guys. And your next year's class is going to be Algebra 2, and if you're qualified at the end of Algebra 2 to move on to the second semester pre-calc, then most of you will be doing that. Some of you might be too fast, and we're looking at doing an Algebra 2 option throughout the whole year. Nothing in stone yet. For those where it's just too fast to accelerate 2 years in one. But maybe everybody can if we give you enough preparation going into the Algebra 2 so that you can handle the speed of Algebra 2. Maybe we can get everybody into the advanced.
2 root 7 is actually a pretty good estimate. If you round to the nearest 10th, they're both 5 root 3.
Okay.
I did that because I said, well, 24 over pi is approximately 8.
All right.
So 36 minus 8 is 28. So the smaller circle is approximately 28 in area. And then I took root 28.
Okay. All right, everybody. We're on slide number 8 out of 19. So we got a ways to go. And we want to test tomorrow because statistically you're going to do better if you take it tomorrow rather than Monday. All right, so looking at this problem, let's get to it. You have an inscribed angle. They want the value of x. So the value of x is a degree measure because you don't have any lengths here. So this can be applied to any sized circle. So it must be an arc measure. So they want this arc measure is what they want. Does everybody understand that? You're not getting the length of that arc. You're getting the measure in degrees of that arc. Okay, so this is a diameter. See that? This is an inscribed angle inscribed in a semicircle.
David, can you at least wait a little bit?
Yeah, David, if you want to give anything, he already put it in the chat, so he knows, he's got it. He's learning.
I mean, you could just put it privately to Mr. Rosenthal, so none of us.
We all just saw it.
Yeah, you can just
Default, it was on everyone.
Grab an answer, put it in the chat. But everybody look here. This is a right triangle. We had a theorem just towards the end of the chapter where it said an inscribed angle inscribed in a semicircle is a right triangle or is a right angle. That means that this is a right triangle. That's a diameter. That makes this angle complementary to the 20. That makes this 70. Then the arc intercepted by the inscribed angle is double the 70. So this arc must be 140. And I didn't even need to write anything on here. Does anybody need me to explain that again?
Can you explain it again?
Yes. An inscribed arc, when it follow that angle, when it intercepts the circle, it intercepts an arc. Well, if that's a diameter, then this arc here is 180 degrees, and this has to be half of that. This has to be a 90-degree angle, right? So anytime you have an inscribed angle inscribed in a semicircle, because there's a diameter here, that's a right angle, which makes this angle here has to be the complement of 20. So it makes it 70. Now take this inscribed angle. It's intercepting the arc that we are trying to find, x. This must be double this angle, which we just said was 70. So it must be 140.
Wait, I actually found it another way.
Yeah, you could.
The other way
find it.
is that this semicircle is 180 degrees.
Yeah.
Yeah. Then
And then
this is
20.
40.
Yeah, 40 degrees, and then
And if you take 40 from
supplement.
180, no problem. You can do it that way too.
Okay.
That's fine. Just be more aware in the future. Oh, okay. I see. You're talking to each other. Should I do? Oh, yeah. I got to make it host only because I had that meeting. So now we're on chat host only. There we go. Sorry about that. Now I'm the only one who can see. All right. Moving on to the next problem. Number 9 out of 19.
Press F to pair specs.
Yes. This is too big, so let's take it down to 200 and see if that will fit. Yes. A chord of a circle is 7.8 centimeters and is 10 centimeters from the center of the circle. What is the diameter of the circle to the nearest tenth? Go. And I'm just going to draw it as you start to do the problem. I won't do it right away. I'm just going to draw the scenario. And what I'm doing is modeling for you how you might approach the problem is by drawing it. And you know, once you draw it out, you see, oh, a few slides ago we did a problem like this already. They want to know what the diameter is. Okay, here we go. You should have been drawing this. We know what this is. When this is drawn perpendicular to that, which is what it means by distance, 10 centimeters from the center is a distance, and what they mean from a point to that chord has to be the perpendicular segment, and we know that the perpendicular segment is going to bisect it, which means that this little leg is half of the 7.8. Half of 7.8 is 3.9 squared plus 10 squared is equal to r squared. Questions so far?
9.
9?
Oh, you use that method? I just did the intersecting chords in a circle method.
That seems like more work,
I guess it is.
but it could be more fun for you, more challenging.
It was.
Okay, when I add these together, I get 115.21. And then I take the square root, and I get that, 10.7. And that's the radius. So the radius is about,
You have to double it because they're asking for the diameter.
that's correct. What is the diameter of the circle to the nearest tenth? 21 point to the nearest
5.
tenth would be 21.5 centimeters. I'll take questions. Anybody? Okay. Here's the next problem. We're going to shrink this down to 190. We just need a small amount of space there. Okay, there we go. Intersecting chords in a circle. Now there's two types of problems with intersecting chords in a circle. There's problems with respect to the angles, and there's problems with respect to segment lengths. That's something you should probably determine right at the, at the beginning of the problem. You should look and say, is this an angle problem or a segment problem? You should stop and clarify to yourself. This is an angle problem. Okay, so you're finding out the measure of angle X or Y, whichever one you find, the other one is a supplement. Okay, so it looks like because they gave you these arcs, you're going to find Y, and once you find Y, then X is going to come with it. Go ahead and do that as I erase and set this one up. Actually, I'm not really going to set this one up because this one is a theorem, and knowing the theorem just allows you to easily do the problem. It's a very easy 4th grade math, 5th grade math problem once you know what to do. The geometry is in knowing what to do. The math itself is basic arithmetic. Oh, I should do it in green. All right, I think you've had enough time to try to think about the theorem. When two chords or secants meet inside the circle, the angle formed here is the average, or the half the sum of the two intercepted arcs, which are this one by that angle and this one by the vertical angle. Those are the two intercepted arcs. Okay, so that angle is the average of those. So add them. 20 and 130 is 150. So Y is 75 and X is the supplement 105. Not much work to do. Of course, on your test, you have to show 1/2 20 plus 130. Then I know you used what formula you used.
I get that they're supplementary, but like, how'd you find 75 and 105 like that?
75 is the average of the two intercepted arcs.
Oh.
Which is what the theorem says. That's only when the two chords meet inside the circle. When they meet outside the circle, it's very similar, but it's not the same. It's half the difference. Yeah, instead of half the sum, it's half the difference. Okay?
Yeah.
Any other questions about this one? We're gonna have plenty of time today. We're moving fast. But we're not delving deep. See what happens there? Okay, find the value of each variable. I'm gonna let you go on this. This will take, if you know the theorem, and I like thinking, when I see this problem, I like thinking about how we figured out the theorem is fun for this one. That's what's entertaining to me. Is the idea behind this theorem was a pre-calculus idea that leads into calculus, which is the limit. It's kind of a limit. Approaching a value, you see a pattern, you see a value, a range value maybe that's being approached. You just can't land on it.
And in some cases, you can't. Oh, I was about to say you can't necessarily approach it.
You can approach, you just can't land on it.
No, I mean what I meant land on. And
Yeah.
you use limit to calculate derivatives, right? unless you're using derivative rules.
Yeah, I mean, you can't land on it, but then but you also can't reach infinity either. So because of the two, by saying, okay, let's say I did reach infinity, which you can't do, but if I did, I would land on it. And because it's almost like the two impossibilities cancel each other out, so you get your value in a weird philosophical way.
Okay, this problem doesn't take that long, so.
All right. What do we know about the theorem? We know that this type of relationship where a chord meets a tangent is the same as an inscribed angle relationship.
Yeah.
So this would be the same as if an inscribed angle intercepted this arc. See that? This arc here. So that angle is half this arc. All right? And that's really the key to the problem, because these two arcs make up the entire circle. So you know if that's 280, then this is 80, because the whole thing is 360. 280 plus 80 is 360. So this arc must be 80, which means x must be half of that. X is 40 degrees. I'm not going to even write it. Questions about that?
Could you do it a different way so that you find the other side of x?
Yes.
And
yes.
then
Yes, because when a chord meets a tangent, it doesn't say which side. It doesn't matter which side. So this angle formed is half of this one, right? So that's 140, right? Which makes the supplement 40 that way as well. Okay. All right. Slide 12 of 19. I'm going to shrink it down to 180. There we go. Find the value of each variable. I'm going to let you get a head start there. Oh, well, no, this one's going to be quick, but I'm actually going to draw this one.
Easy.
Yeah, this one's not. Okay, that's enough time. Here's an inscribed angle. What you don't want to do is get it mixed up with the central angle. The central angle is congruent to y, the arc, but the inscribed angle is half. So that means y is 44 degrees. Okay? Well, now you've used up 164 degrees, which that's not drawn correctly, because if it was it can't take up 164 can't be here and be more than half the circle. It has to be less than half the circle. So it's these should have well, I guess you could have a 22 degree angle go on opposite sides, but then that wouldn't be 120. Okay, so it's not drawn to scale, but don't worry about that if that happens on the test. It's not.
They never are drawn to scale.
Yeah, it's not necessarily drawn to scale, so don't worry about it. So it's
Don't try to measure the angles with a protractor.
164, so it's 360 minus 164, which is 196. Yeah.
Just get the 16 to 180 and then add.
Wait, Ms. Rosenthal, can you review that one more time, please?
Okay, so you see how I found this piece? It's double that inscribed angle.
Yeah.
Now you have 120 and 44, leaving you just x. The whole circle is 360.
Okay.
Okay, so the 120 and 44 is the 164 subtracted to get x. Got it?
Thank you.
Get it? Got it? Good. Any other questions?
Oh.
Okie doke. Okay. All right. Don't make them, don't just go, oh, that's the supplement of that. No, it's not. No, it's not. That's only when these are tangents that's supplementary to that. Be careful. Take your time on the test. Look at your notes. Check. Try not to use your notes if you don't have to. Be a master. If you use your notes, you have not mastered it. You are a master when you do not need the notes.
But you are a master of notes if you use your notes.
You're a master of notes. Good.
How is that much of the circle 100?
Not drawn to scale.
This is really, really not drawn to scale.
As opposed to just a little not
It's
drawn.
somewhat drawn.
Yes, as opposed to just a little.
Well, I apologize. Okay. I'm sorry.
You should be.
I am. So I'm doing what I should do. What I ought. Can't get an ought from an is. You guys, did I explain that to you already? Ought from an is? Or was that my
No.
pre-algebra class?
No, you did not.
I'm sure Surin knows about that. Philosophy, it's still being argued to this day. It's an ancient argument of morality. Ought is what you should do. Is what is. Facts. How do you get an ought from an is? And philosophers debate that there's nothing universal about it. And some say that there is. So
Are you a relativist, Mr. Rosenthal, or do you believe there is a universal concept of morality?
I don't know. Isn't that exciting? I don't know. I get to contemplate it. If you know everything, how boring that you don't get to contemplate. Okay.
Well, at least you know the answer.
What?
That's always satisfying.
What that I don't know?
Oh, that you know the
Sometimes it's better
answer.
not to.
That I know the answer to what?
He likes knowing.
Any question, yeah.
I to think about things.
I do like to think about things. I just prefer to know about them before I think about them.
Interesting. So that you can know.
Actually,
What are you thinking?
learning about them is also thinking about them.
Mm-hmm. All right. So another mistake I could see a student making is thinking that this angle is half of the 100. It's not. It's only that's not an inscribed angle. I heard a student think of that as an inscribed angle. That's not an inscribed angle. Okay. So you have 100. You have 150, and that's like almost all the. So that's like 2/3 of the circle. Probably what David was talking about. All right. But you have 2 arcs left unknown. So you might be thinking, well, then I can't know what's what. But you do know that this angle is formed from 2 secants meeting outside the circle. So that 40 is half the difference of these arcs. And you can go ahead and calculate that right now. Okay, so 40 is equal to half the difference of the bigger arc minus the unknown y arc. And you'll always double both sides. So 80 is equal to 100 minus y. And we'll flip-flop here. I'll add y over here, and I'll subtract 80 over there. So y is
Toggle.
20 degrees. And now you can go ahead and find this arc here. Be careful. This is where students fall down. You are not finding x. X is the angle, not the arc. Okay? So far I have 170, right? So I have 190 left. Yeah, you're right, way off. That little piece should be more than half the circle, all right? Angle x has to be half of the 190. So x is half of 190, which is 95 degrees.
X is certainly 95 degrees.
Yeah, it's an obtuse angle.
It's an obtuse angle.
Why is y equal to 20? Like, I see the equation, but like, why is that correct?
there was a theorem that we proved saying that this angle has to be half the difference of these two arcs. So I set that equation up. 40 is half the difference of the two arcs.
Okay, Mr.
Solved
Rosenthal.
And it gave me 20. Yes.
Why is x 95 degrees?
X is a tangent meeting a chord. That angle is half the intercepted blue arc. X is the angle, not the arc. We were finding the angle. The angle is half the arc, not congruent to the arc.
I heard Jack say yeah in the background.
Oh, yeah. It's tough, you know. They need an education too. And, you know, while we're both full-time working, so we have to take turns. And they're going a little haywire too, being cooped up. They're little kids, you know. They need
Everybody's going haywire.
Yeah, everybody's going haywire, exactly.
I like being haywire.
We're going haywire together, and so it's a shared experience somehow. Okay, any questions about this problem? So this one...
Haywired is the new normal because everybody's being haywire.
Yes.
Wires should be copper, not hit.
So this problem we're going to get wrong. This problem gives a lot of wrong answers. A lot of students miss this one on the test, especially when they're finding X. Half the students get Y, only a quarter of the students get X. Okay? So be careful on this problem. Put an asterisk next to this problem. Make sure you practice this one. This one is heavily missed. If I tell you that it's from me seeing year after year after year of the same thing, it's statistical. You know, it's like, that's what's, you know, you can count on it. Vegas counts on the odds. It's not that it's a certainty. Don't get fooled by that whole it's not a certainty thing. You know, I could roll the dice and roll a 7. You know, I could win, you know, on a slot machine, a jackpot. I could do, but that's not how it works. You know, they can count on it. And I can, having seen it year after year after year, I can count on this problem being heavily missed.
Mr. Rosenthal, as someone who loves graphs and charts, I think you ought to keep a statistical record of exactly which questions are missed how many times on every test and what the average score and individual scores for every class were for every test in every chapter. That would be very enlightening for very enlightening for a teacher such as you who teaches quite a few students and thus would require statistical advice in order to formulate strategies that allow them to continue along with the best possible course.
Yeah, you mean so students would believe me?
And
No, I don't think they'd believe. It's not necessarily about them believing you or not. It's about it being used. It's about the data being useful for you in order to determine how and when you're going to change the curriculum, or why, or what you're going to advise the students to do. It would also be very interesting to see if the total class quality has improved over time since you first began teaching.
Yeah.
You can also keep track of the type of students that miss certain questions.
Absolutely, missing one component of that, which a lot of people miss this, is the cost-benefit analysis. It's not that that's not beneficial.
No cost-benefit analysis.
It's extremely beneficial. It's extremely costly, time-wise and energy-wise, to do that.
You can have someone do it for you.
Now, here's the thing. How did I know? I haven't done this problem in a long time. Years, many years. I still remember this being missed. So it's really not the amount of benefit, it's the marginal benefit. How much extra benefit on top of what I already had. So you don't measure benefit versus cost. You measure marginal benefit versus marginal cost. It's extra benefit that I get by doing it rather than not, versus the cost of doing it rather than not. There could be other costs that are going to be there no matter what anyway. All right, so we call that the marginal amount. All right, and you'll learn that in economics if you take an economics course.
You could reduce the total cost by having someone else do it for you.
Yeah, you could do that.
Tell Son to do it. He wouldn't be interested in everybody's test scores.
Who's going to do that?
Son.
I was about to suggest. Thank you, David.
Son would be very interested in everybody's test scores.
Yeah, you can't have a student do it because
Not for that reason.
Course, like of other students.
I like statistical modeling. That's the thing.
yeah, I mean, it's good, but I already know that this is heavily missed. I already kind of have an idea. It's, you know, when you're seeing a trend, you can now, the accuracy of my remembering it is not going to be as good as hard data. No way. But I can tell you the important part that you want to take with you. That's why I asked you, is it because you want the students, more students will believe it if they can see it in data rather than not? I don't think it is. I think that students don't necessarily make good choices. I think that's just going to be the case whether I show them that. That's why maybe I'll squeeze a little bit of marginal benefit out of that for a tremendous amount more cost.
I know for me that if I looked at hard data, it'd be much more solidifying the idea than just listening to you say something that I'm like, memory might change. You might mix up this problem with a different problem that people mess up on, and so on and so forth.
Think of
It would be it would be
That's
beneficial to
anecdotal.
Mr. Roosevelt. It
That's
would be beneficial.
That's anecdotal. You know, that might be the case for you. But when we
Yes,
talk, you have to be careful when you talk statistics. You can't talk about individual testimonies of things. You
I
have
was
to
speaking.
talk- Yeah, go ahead, sir.
Oh, sorry, Mr. Roosevelt. I was speaking concerning the benefit to you. Wouldn't it be beneficial to have an accurate statistical model of how, when, and why students are failing exactly, exactly in what regions they have
Yes.
problems?
Yes,
Wouldn't it be beneficial to finish this review so that we can take the test tomorrow?
we're gonna finish the review. This is slide 13, right? So we don't
Okay.
have many more to go. 6 more slides. 25 minutes to do 6 slides. We're gonna be okay. And a proof. We should get on, actually. Okay. Yeah, so it would be marginally beneficial, but not much more marginally beneficial for all the cost. In the end, students need to make choices and learn from poor choices and from good choices. You should learn from your good choices too. Okay, now we go back to something we already saw. Chords meeting, intersecting inside the circle, except now this is with respect to segment lengths instead of angle measures.
That 3.
Yeah, that's a 3.
Okay.
So what you should know here is that along a line, coming through that point of intersection, we called it point P when we showed this, right? We went PA1 to PB1, right? The 2 locations along that line where it intersects the circle. The product of those 2 is constant along any line that goes through that point and intercepts the circle, okay? It's constant. Even if it's a tangent, all right, you're gonna see that it's gonna be constant, all right? So let's do this first case. There were 3 cases. This is when you have 2 secants meeting or 2 chords. 3 times 16 gives us a constant. So that means any other line coming through, the x times the 12 or 12x is equal to 48. The value of the variable is 4. Okay.
So you're saying that like there's those I don't know, chords are similar?
It's not that the chords are similar. It's really when, you know, when two lines go through a point, that line and that line, these distances, the product of these distances and these distances are equal.
Okay.
Yeah. From the point to the circle, 2 ways. Remember it that way. From the point to the circle, 2 ways. Each way constitutes a value, a length value. How far, right? You're measuring how far is it to the circle one way, how far is it to the circle the other way, the opposite direction along the same line, right? You can't go X and then 3. You can't change course. It's along the same dimension, right? Along that dimension to the circle twice. 1 way, 2 way. Those have measures. When the product of those measures along any line, an infinite amount of lines that go through that point, change the point and you change the result. You change that 48. The product, it has to be 48 going through that point. Going through that point, it has to be 48. So any line that comes through that point, any line, the product of those two lengths is 48. It's always 48. Change the location of that point anywhere else, and it will be different. And if you want a simple case, use the center. Draw a diameter and another diameter. Well, it's radius times radius, and then the other one will be radius times radius. It would be the same. It would work if you use the center. All right.
R squared equals R squared.
Try this one. Now their second case. They're meeting outside the circle. Let's see what you remember about this. This one is heavily missed. Take my word for it. For a very simple reason, but not trivial. It's the same reason students miss that geometric mean one. So let's remind us of that geometric mean one. Okay, so if I have that this is 4, because I have an altitude drawn, here's a right triangle with an altitude drawn from the right angle to the hypotenuse, then 4, that leg, is the geometric mean, and students would put of 4 and 1. Wrong. It's not 4 and 1. It's 4
and 5.
and 4 plus 1. That's the situation why students miss this problem. Same thing there. Okay? So this one is the square. This is 2 root 5. Oh, no. Yeah, this is 2. Wait a minute.
Nani?
Well, I mean, so this is wrong because if you have a, well, no, okay. So yeah, this is wrong because this would be a 3, 4, 5 right triangle, and that the altitude would split it a certain way that wouldn't be 4 and 1. That's why you got an impossibility, by the way, if you were wondering about that. Okay, the point of that was though that the same reason students get that wrong is the overlap thing here. All right, so let's set this up. If you remember it the way I'm trying to tell you is from that point to the circle 2 ways. To the circle, boom, you hit the circle. Record that 5. That's one out of the 2 factors that's going to build your constant. Okay? The other one is going to go from that point to the circle, hitting it at the other point. It's not 8. You traveled the 5 and you traveled the 8. Okay, so remember, it's the 5 plus the 8. Don't forget that. All right, so 5 and 8, that's what students are going to miss. They're going to do 5 times 8. They're going to do 5 times 8. Please don't do 5 times 8. 5 times the whole thing is 1365. All right, so from that point, any line coming through, when it, even a tangent, when it hits the circle, 2 ways, that product of those 2 factors is always going to be 65 from that particular point.
Shoes or sneakers.
Okay.
Whatever you call them. These rubber-soled casual.
Hey, mute yourself, please. By the way, I just realized some sort of corollary to that. If that one is 65, then I would say that the relationship between that point and the center, there is a certain distance. I wonder what we could prove about that distance, because I think all the points that are that same distance that make a concentric circle with the other circle, all of them, there's no reason why that point that's the same distance as that one wouldn't also have that same constant of 65. I wonder if we could go and prove something about that. Can we, by knowing how far that one is away from the center, would we be able to know what that is and use that as a tool? That's an interesting idea. Anyway, let's get back to the problem we're on. Now I can find the variable because I can say that, well, from here, this x times x plus 10 has to be 65. It has to always be 65 from that point when I'm hitting the circle. Okay, so now you have x squared plus 10x. I'm going to go ahead and subtract the 65. And yes, you are going to get a quadratic on the test again. And we had that earlier in the year, earlier in this semester. Okay.
I didn't believe how useful the quadratic formula was back then.
Yeah.
Much faster than x factoring or completing the square.
Actually, sometimes factoring is faster.
Well, it's complete.
I don't think this one's factorable, is it? 13 and 5, that's it.
And that's the thing. Some of them might not be factorable either. Quadratic formula solves all of them.
Well, I better pick up the pace here. Okay, negative b is 10. This is 10. Here's a is 1, 1. C is negative 65. So I have negative 10. That's 100 plus 260. Okay, is 360, which is 36 times 10. So it's 6 root 10 over 2. I can't subtract. I'm going to get a negative. X can't be negative. Get rid of that extraneous solution now. Okay, let's get our calculators out and see what this comes out.
Divide 2. 10 2.
Well, I don't need to. What I'm
Negative
gonna,
5 plus
I'm going to get this.
plus
I'm going
root
to divide
3
by
root
2 again. 10, square root of 10. Okay, times 6. And I'm going to subtract 10 from that and then divide by 2. So x is about 4.5 units. Questions?
Question.
Questions? Okay. Slide 16 out of 19. Find the value of each variable. Okay, this is just case
We
3.
can't see the screen.
Mr. Rosenthal, could you move up the that's better.
Stop yelling at me. So we have a tangent now and a secant. They're meeting outside the circle. It's really the same problem as last time. If you follow what I'm saying, from this point to the circle, because it's tangent, there's only one point, so you got to go twice. It's x times x, or x squared. And that's got to be equal, from that point, it's got to be equal anywhere you go, secants or tangents. Okay? So this would be 4 to hit the circle in one point. It would be 4 times the other factor would be 4 plus 12. 64. Perfect. X squared equals 64. X is plus or minus 8, but it's only positive 8. That one's done.
Yeah.
Yeah, I was about to say yay. Questions?
No.
You don't know that.
Yeah.
You're just
Oh,
silent.
Mr. Rosenthal.
Mhm.
Mr. Rosenthal, when you said it would be we would statistically do better on the test if we took it tomorrow, well, I can say for a fact that it might not be for quite a few people in our class because we also have a science test tomorrow. That's the fact.
Yes,
We have
but
science
the math test is in the morning.
We have to prepare simultaneously.
Here's the thing. Here's the thing.
No, we
night,
don't.
but
We're already preparing right now,
Okay,
so the
you don't
math
wanna know.
preparation is done.
You don't want to know.
not necessarily. Not for
Fine, be
most
quiet.
students. They
No,
might have
don't tell
Just-
people to be quiet. Listen,
Yeah, but
here's the thing. The thing is that I've already made up. First of all, I made up my mind. It's going to be tomorrow. So there's no.
Let's silence
But I
the
can
voice
tell
of
you,
the people, Dave.
I'm going to tell you the rationale is this. I do want this to be committed to long-term memory, but there's nothing I can do to change the fact of the biology of the human brain is that there is an advantage to short-term memory. It just is the case. And the longer you go before you take the test, between the review and the test, it's going to have some, whether it's minor or major, your short-term memory of this material, it will dwindle it's going to be proportional. Everybody will have their own constant of proportionality, right? That will change, it will decrease, it'll be negative. It'll come out of your head. Some it'll be minuscule, and others it will be more. It'll vary between the participants, but everybody will have some loss of short-term memory on this. That's, I believe, a big variable in providing the advantage taking it Friday.
Mr.
Okay.
Ostall,
Yes.
just a question: would you rather have them have a small loss during the time it takes for that information to transfer from their short-term memory to their long-term memory, or would you rather have them prepare for 2 tests at the same time, thus making it harder to prepare for each test individually? It's a very massive inconvenience for us.
Ask your other teacher to postpone the test.
We're already preparing for the math test right now.
Yeah, 2 days.
No, David, this is assuming you prepare the evening before, not just when you're reviewing, okay? There are students who study for the test the evening before. For them, it's inconvenient to have to study for 2 tests at the same time, and that's quite a few students, so it's not as though it's a statistical minority. It's very inconvenient when...
You can study for the science test before it.
Listen,
on
we're
tomorrow.
out of time. I have 10 minutes and 3 slides, so listen.
David, those are
Guys, let's not talk
circumventions.
about this right now. You're taking
basics.
time away from
Sure,
the
yeah,
review.
we can't continue the conversation. It's going to be tomorrow, unfortunately, and when you get to college, you're going to have midterm week. All your midterms are in the same week, and finals week. All your finals are in the same week, and your whole grade sometimes is based solely on your midterm and final only. In a lot of classes, that's what you're going to have. Your whole grade is based on the midterm and final, and that's it. That's it. Okay? So if that's the case, you're going to have to deal with that, So let's get moving. Write an equation of the circle with this center. Watch what I do. I'm going to go right into it. X minus that center H. That's not X and Y. That's H and K, right? Squared plus. Why is it plus and not minus? Because it's always Pythagorean theorem. It's a squared plus b squared equals c squared, okay? So this one is y plus 4 because it's minus negative 4, okay? Squared is equal to r squared. It passes through that point. So what I'm going to do is I'm going to substitute that x and y for that x and y. So 7 minus 13 squared plus 4 squared equals r squared. Okay, I just need to find out what r squared is. I don't need to take
6 plus 6.
I am not going to need to take the square root here. Okay, this is negative 6 squared is 36, 64, perfect, 90, 100. Students are going to get this wrong because they're going to take the square root. Don't take the square root. You want the equation. The equation is, go back to where you started, x minus 13 squared. Some students will get this wrong because they're going to make that negative and they're going to make this one positive. It's the reverse. So you got to remember that. Y plus 4 squared equals 100, which is r squared. This is your final answer here. Questions?
You could also do it by just using the distance formula.
Yes, you could. Look at that.
Takes longer.
A point and a center, right?
Really, it's a 3, 4, 5 triangle.
We had to do it that way in the homework.
But, I mean, this is the distance formula right here, right? x2 minus x1, y2 minus y1. y2, 4 minus negative 4 is 4 plus 4. This is the distance formula. It is the distance formula. It's not that you would be doing something really different. Okay? Moving along, two slides to go. Find the circumference and area of the circle with this equation. Well, what do you need to be given usually to find the circumference and area?
Radius.
Radius. Well, we got it. What is it?
14 noon.
No.
7.
It's 7.
Oh.
And now go to town. There we go. So circumference is d pi. So 14 pi. Leave it in terms of pi. Okay. Units.
It doesn't say to the nearest tenth.
Units. Area. Pi r squared. Okay, well, 49 pi square units. This is one of the easiest problems on the test if you know what you're doing. I'll probably give you 2 points for it. Maybe not.
Do we leave it in terms of pi?
Yeah.
Yes, because it doesn't say to the nearest tenth.
We're going to be pressed on this next problem here. But you can go back and watch the video. It looks like this one is recording, so hopefully it has enough disk space to save it. We'll see. Okie doke. The proof. You know, honestly, I don't even know if I should have the proof on it, because all you guys can do is just, you'll have the proof in front of you. You don't even have to rethink it. So it doesn't make any sense for me to even count the proof on there. So
Hi, Mr. Rosedale, count the proof. No.
I'm probably not going to
count the proof. Don't count the proof.
I don't know how I could.
No way, count it.
Well, how would I?
It'd just be extra free credit.
How about I just show you that's the proof, and can you prove it without me doing it so that you don't have any notes?
No,
yeah, that's
Please.
No, you should show us, and
No.
it should be on the test, but you shouldn't give us a lot of points for it.
How about no points?
Just a
It would
few.
just be
No,
copying.
not no.
How about he doesn't show us?
Okay,
No points.
what about
Show us
we have
and
to
it's-
show us
understand the logic.
Don't do it so he doesn't show
and
us.
just don't put it on
We
the
have to-
test.
show us and no
No,
points?
Show
no,
us and
no,
not on the
give-
test.
Show us
no,
and no
give us.
points.
We have to. No.
Just with a lot of
make
points.
extra-
Sir, that's only
One at a
you.
time.
extra credit.
One at a
David,
time.
not everyone is smart enough to figure this out on our own.
Make
Okay,
it
but
extra
remember-
hey,
We
you
have
guys
to
can chat tonight about how to do it. There we go. So what I'll do is I will not do it, and I will put it on the test, and you should be able to figure it out. Okay?
Wait, what?
Oh,
Oh,
You have to figure
Hey.
this out without my help.
Just talk
Fair.
to the smarter kids on Discord.
Ooh, you're gonna have to
David
think
and
for
Saren, I
yourselves.
blame you.
Think for
It's not that
yourself.
we're upset about that. It's just
Don't be upset that you're gonna have to think it out yourself. That's what we want you to do at the Science Academy.
Why have you done this?
We want you to be able to figure it out yourself. Okay? So good. Now you can work together. Ask each other for help. Do it. Work on it now together so that you can then put your
Radii,
answer.
HL.
Okay?
He said ask for help, not get help pushed on you.
Yeah. Okay. That being said, we're not going to discuss this problem anymore. I am now going to go to office hours. You guys are all dismissed. Good job.
Thank you,
So
Mr.
no
Roscoe.
proof.
yeah. He's not. He's
Yeah,
not.
no,
gonna
Just
explain
stop
it.
I'll just re-clarify.
There.
Oh, could you go?
Was that
Mr.
the last
Rosenthal,
slide
Could
on
you
the
go back
review?
up to the given? Could you go back up to the given?
oh, Mr. Rosenthal, can you show us the proof?
No. I just said I'm not going to do that.
I'm just kidding.
Mr. Rosenthal, I wasn't here yesterday, and you said you'd go over it. Can you go over slide 7 by any chance?
Yes.
So we're done. Bye.
Yeah. Bye.
I'm done.
I didn't get the given.
Wait, Saren, you did the proof already?
Thank you, Mr.
I got the
Rosenthal.
given.
Circle O
I'm pretty sure just prove
and
it by
chords.
You do it with HL, like David said, by extending the
Drawing the radii.
right triangle.
The
Yeah.
chords, yeah.
Okay.
Wait, but what do we need to prove?
You're trying to
The chords are
find
congruent.
You're trying to find this arc here. Okay?
Oh,
In
we proved
slide
this.
number 7. Okay, so what you're going to need, draw those out, Thomas. And that theta and that theta are the same because these triangles are the same. Why are the triangles the same? Well, this is the same as itself, and all radii are congruent, right? So, and they're both right triangles. So by HL, the triangles are congruent. So by CPCTC, those angles are the same. So if I find one of these, okay, if I find one of them, then I can just double it. So this central angle here is congruent to the arc I'm trying to find. So 2 theta is going to be my answer. You see that, Thomas?
Yes.
Wait, Mr. Rosenthal, isn't that pretty much how you?
This central angle has the same measure as this arc. So, and that's made out of 2 of these thetas. How do I find a theta? Well, I have 5 and I have 4, right? I have opposite and I have adjacent. Okay, so arctan of the ratio gives me the angle. Okay, 5/4.
Sorry, I can't hear you over the people talking. Like it cuts out. Can you say that again?
Yeah, so the inverse tangent, or arctan, is inverse tangent. Oops. Of the ratio, opposite over adjacent, is going to give me the angle. So then in my calculator, I'm going to get that 5/4, which is 1.25. And I'm going to do inverse tangent. And that gives me a 51-degree angle. 51.34 degrees is theta. So 2 theta, I'm going to multiply that by 2. Don't forget to do that. I'm going to get about 102.7 KISS FM degrees. And if we say round to the nearest whole degree, then you can even say it's about 103 degrees, this angle, which means that the arc is 103 degrees, about.
Wait, can you explain how to use inverse tangent again? I'm sorry.
Yeah, I mean, tangent we define as tangent of an angle is a ratio of opposite to adjacent. Inverse tangent of the ratio gives you the angle. So what I do is if I had this, tangent of theta is 5/4. Inverse tangent of 5/4 gives me theta.
Arctangent.
Arctan, yeah. Arctan, and we're going to slowly transition into arctan.
Okay. Can you go over a few other ones by any chance,
Yeah.
or does it take too long?
No.
Can you go over slide 2?
Slide 2. Okay, so the theorem is that when a radius is drawn to a tangent at the point of tangency, that segment is perpendicular to the tangent. So you have a right triangle. So you're going to use the Pythagorean theorem, but there's one thing to be cautioned about. This is x, this is 8, this is not 12. What is this distance, Thomas?
Is it 8 plus 12?
Yeah. That's where students mess up. They say that, oh, the hypotenuse is 12. No, it's 12 plus this is 8 because it's a radius. So it's 20. Then you just use the Pythagorean theorem and get x.
Unfortunately, it's a 2, 5, whatever.
Questions?
Yeah. So 400 minus 64.
Okay, this is. Any other ones that you want to see?
Oh, sorry, I'm just doing the work for this right now.
Oh yeah, go for it. I'm here for office hours. I'm good.
Okay.
6, 7, 8. Here's a proof that I made up myself. Given cats. Step 1. Step 1, cats are cute, but the cats are cute theorem. Step 2, cats eat mice, but the cats are useful theorem. Step 3, get a ton of cats. Quadratic demonstrandum.
QED.
Yes.
You're calling it the Latin?
Yes.
Quad erat demonstrandum?
Yeah, that which was to be demonstrated.
Anybody else while Thomas is doing that have anything they want to see?
So is it 4 root 21?
I don't know. 20 squared is equal to 8 squared plus
1656.
6 squared. So 400 minus 60.
4 root 21, yeah.
330. It's the square root of 336.
4 root 21.
So you could do that in your calculator.
Can you do slide 3?
18.3. Sure. Yes, I can do that.
Sorry, I might just be going 3, 4, 5 until the slides will catch up.
No problem. Office hours, that's what this is for.
Okay, thank you.
You bet. You could see how if we were short on time, if I would have done this during the lesson, we would have had a problem with finishing. Okay, so this whole thing is 8, but if that's perpendicular, then it bisects it, so it's 4 and 4. That's what you should know. Okay, now there's different ways of doing this, but what you could do is make a right triangle here. Well, look at that right triangle. It's a 3, 4, 5. If the radius is 5, then x is 5. Done. So the trick is connect that to make a triangle.
The radius is 5. I tried doing it with Pythagorean theorem, but I got something else.
What were the values you used?
I did 3 squared plus 4 squared equals x squared.
Yeah. 9 plus 16 is 25. The square root is 5.
Oh, I accidentally got. Ooh, whoops.
It's
Sorry.
a 3, 4. It's a 3, 4, 5.
Oh, okay.
We don't really have to work it out. 3, 4, 5 is already a triple.
Yeah, we want you to know 3, 4, 5, and at least
5, 12, 13.
At least those two. 3, 4, 5, 5, 12, 13. If you know some of the others, that's great for you. I don't remember the other ones. I still, even though we went over that a couple months ago, I don't remember that. One of them was I think 24, 25, something. 7, 24, 25, maybe.
Oh, okay.
Hey, Mr. Rosenthal.
Oh, sorry.
Yeah.
Mr. Rosenthal, you know how for like the proof, you have to draw lines, right? For the theorem on the test. Do you need to write a theorem for that?
Do I need to write a theorem for what?
Wait, is there a
Postulate 1-1.
Thank you.
Oh, if you're going to draw an auxiliary segment, yeah, you can do postulate 1-1.
All right, thank you.
Or you just put it in your diagram.
And I don't have to write anything because that's what I did.
I mean, it depends on how. I'm not going to get you on not being perfectly, specific about every detail. I'm not.
Proof on the test, is it going to have to be 2 column?
By the way, the publishers don't. It becomes trivial at some point once you understand that's part of it. You're welcome to put it in there. I know some of us enjoy being very specific and distinct. Yeah, and I do at times also. My first time around taking geometry, I was just like that. I wanted it to be as distinct and break it down into as many parts as I could to show it. But I've done it so many times, I don't want to keep doing it. It becomes trivial at that point.
Does it have to be 2 column, the proof on the test?
The what?
Next slide.
Next slide.
Okay, Mr. Rosenthal, on the test, do we have to put it in 2 columns for the proof?
Yes.
Okay.
Are there going to be questions?
I guess you can do a flow proof. I do it however you want to do it.
Can we just do it in a diagram, like a show?
No,
Or
it's
does it have? Okay.
It's got to be a proof.
Are there going to be questions on the test like the warm-up?
The questions on the test are the ones on the slide exactly.
Okay.
Thank you, Mr. Rosa. Have a good day. See you tomorrow.
You betcha.
Bye.
Thank you for your inputs. They're very valuable to the lesson.
Hey, who did that?
Me.
Bye.
So in this case, what you could do is label that an unknown y, and then that one's y, because when this segment is perpendicular, it breaks that x into 2 pieces, so that 2 of the y's will make up your x. That means just by finding that y with the Pythagorean theorem is all you need to do. And I'll let you do the calculation just for time purposes. I assume that you can do 121 minus 81 is 40. Square root of 40, 2 root 5. So if y is 2 rad 5, then 2y is 4 rad 5.
Wait, isn't root 40 2 rad 10, not 2 rad 5?
2 rad 10. Let's see. Yeah, I think you're right. Square root of 40 is 4 times 10. Yeah, 2 rad 10. Yeah, so 4 rad 10. Thank
And
you.
then times
4
2.
rad, yeah, 4 rad 10.
10.
Yes,
Okay.
thank you. Square root of 20 is 2 rad 5.
I'm pretty sure I'm okay with the standard equations, but
Is that number 5?
yeah, but I did this question, so how do we show work for this? Because I know that the center would be 5 comma 7 or 5 comma negative 7, but
You don't really show work for that. Just identification.
before
If you want to show work, you can write the standard equation. Right? Write this one underneath. What am I doing? Okay. H is 5. K is negative 7. R is the square root of 8, which is 2 rad 2. Okay. I'm just drawing it out. I'm not gonna ding you on that.
Oh, okay.
But look, if you want to, look at all that I could produce if I wanted to.
And for the last
When students say they can't show work, they're just not using their imagination.
Okay. The next slide is my last question because I think we just stopped off there.
Okay. Okay, this one I don't need to do anything. Okay, look, a couple principles here. We had a theorem that said if two chords are equidistant from the center, then they are congruent. We also had a theorem that said that congruent chords intercept congruent arcs. So the first thing we determine is because they're both 4 away. Now, how do we know they're 4 away? Because they're perpendicular segments. The perpendicular segments, given those boxes there, those are the distances from the point to the chords. So those are given as the same measure, so they're congruent. So the chords are congruent, and so the arcs are congruent. So the measure of arc XY is the same as arc AB. So it's 40.
Okay, thank you.
You betcha. Anybody else have any questions? Please answer. Are there going to be questions on the test like the warm-up? Oh, you already asked. No. Nate, are you there? I am going to type a message to Nate. Okay, anybody else have any questions?
Thank you, Mr. Rosenthal. I'm gonna go.
Okay. All right, I'm going to end the session then. Take care, everybody.